This is the waveform analyzer in logging mode, so I can see the lines of code running while the log is running at the same time, and I could capture hours and hours of data, and I can roll back hours and hours of data. So in this case, I could see errors in the code where I've told it to go to sleep, for example, and the modem takes about 6 seconds before going to sleep. However, I've noticed errors in the code where I've said going to sleep and the modem should go to sleep, but actually it doesn't go to sleep. It takes about 20 seconds before actually going to sleep. So I've been able to debug the modem and the current profiles in different sections of the code, so I can see the code running, for example. So if I reformat transmit, there I can see current spikes that I couldn't see before with the waveform capture, with the triggers. And I can see when it takes signal, we've got signal, and now I'm transmitting. So now at this point here, I'm transmitting. And here I'm waiting for a response from the modem. And at this point where it times out, and then the modem should go to sleep. Yeah. But this allows me to characterize waveforms, and I can have it logging for about 24 hours, and I can compare 24 hours of captures and scroll through them on my computer. This is a very, very handy piece of kit. And for example, RTC wake-ups, I can see the current profile in RTC between one transmit and another. So I can also see the transmit time is about 40 seconds, 1, 2, 3, 4. And here's another RTC tick in the next minute. And I could see that. It's very handy to have this rolling data, and I think it's worth a license, because this setup, for every waveform capture, normally, it would take me about 10 to 20 minutes to capture that, because I've missed so many captures, and when a new capture comes, sometimes it ignores the previous capture, and if a capture takes too long, it's hard to find out. So any of the edge cases, it's very hard to capture that data, and if the wake-ups look different, it's very hard to see that. So yeah, it is definitely worth it in the fees alone that I've spent trying to get captures, get it to capture properly.
Here's the data now in the current waveform analytics software. This is on my computer now. I've exported the data from the device after data logging for 24 hours. I've logged 2 different channels, which is 2 different devices, for 24 hours, and I've got their waveform. Now the waveforms look like this. This is a transmission, and this is 2 waveforms, the yellow and the blue. And every minute there's a watchdog reset. So here's every minute, and every 15 minutes there is a transmission. The file sizes do get quite big when you're dealing with 24 hours, so this is a 14 gig file. And every 15 minutes the device transmits. The first thing we want to do is we want to find out how much energy was taken in 15 minutes. In 24 hours. So if we go to analysis and we're looking for the trend, here are data from 2 different devices. This is channel 1 and this is channel 2. In channel 1 we had an accumulated energy of this many coulombs. We can change this to amp hours. So we have one device consuming 93 milliamp hours, another device consuming 70 milliamp hours. Before doing this, if I didn't have the software, I would have taken the area under the curve of one device, one transmission, and multiplied it by how many transmissions per day. If I turn off this channel, and I can pull up an area under the curve, and this is how many coulombs or amp hours. You can change the units in the software, and multiply it by the number of times, and I had the estimate as 78 milliamp hours. So one device is 70, another device is 93, and really the energy, why there's a difference. If I drill through the max max energy, there are two items which are higher than 800. Normally you'd expect 800 on a typical waveform. We would expect, for example, this one. If I drop the axis, we would expect right at the beginning, when the modem turns on, it consumes around 800. But we can go to measurements and we can look at the vertical max, which is 836. And normally we'd expect around 800, 836. So the rest of these, but there were two transmissions which were higher than expected. One here, and one right at the beginning. It's actually here. We ignore the one right at the beginning, that might be me resetting the device. But the one here, the device wasn't touched. So it's quite interesting to see this in the program behind. So you have to right click and export the axis, and then apply it to the CX3300. And this brings this waveform to here, but I think I have to zoom out to make it showing. Is it this one? Maximum, yes. It is this one. So in this case, we had a wake up every minute, and then there was something else, like a blip in the system. I don't know what happened. It might have been a watchdog, because we'd expect every minute, but this is less than a minute. Something happened. So if we move the so we're at 30 seconds. Okay. Something happened for 40 second mark, which caused this device to go into some strange mode. It did recover, but this is worth investigating in the logs. I need to check the logs for that. But it does highlight what you can do, and you can do 100 hours, 4 days, 3-4 days. Another feature of the software is it allows me to look at the trigger points. So here there are triggers. Every 15 minutes there's a trigger. And I could ask it to look into these wake ups, see if it finds any trends. By doing a trigger on this waveform, so I can do a trigger on this waveform. I can zoom in. And I can tell it I'm interested in this specific waveform here, and I can do trigger, and I can generate from the display waveform, and it would do all the settings for this trigger. Actually, I should bring two waveforms on the page. Yeah. Yeah, and it's doing a 24 milliamps halfway, and it will work all of this out for me. The maximum timeout is 1 second, so you cannot have a waveform longer than 1 second. So the transmissions, the whole transmission cannot be categorized as a waveform. And then you go to play to retriggering, and you start retriggering, which generates all of these waveforms. And then you go to waveform analytics, but actually I've done this before. So if I go to the waveform database where I've triggered before, and these are the segments. And if I look here, I need to drag out the waveform. Ah, there they are. These are the different segments for the wake up. I think L8/8 might be the difference. Let's have a look at this one. yes, this is the wake up. Is this a big wake up? No, not in this case. But it is a wake up which was bigger than expected. And it helps find out the big ones. There's also 120 milliamps. So if we ignore the two big ones, it should be around 12 approximately from 1222, 220 waveforms were good, but there were a few bad ones. This helps identify some of the bad ones and what happened beforehand. Yes, so this is probably an unexpected waveform. And if I run the maximum on this, yes, so this is the one that was big. Yeah, this is the one. And it got picked up in this. The rest of them are all fine. So you can use this to work out whether you have suspicious waveforms on your device. But yeah, this is a tricky one. Yeah, that was 300 milliamps. In terms of its on time, if you compare it versus another one, it's actually a very short on time, which is interesting. So it didn't normally the device wakes up and goes back to sleep, resets the watchdog and then goes back to sleep. Normally it's around 200 milliseconds. No, it's less than 200. 200 take away 120. But this one right here, it doesn't last as long, and I'm not even sure if this what was happening here. It didn't even look like the device is waking up or even work properly. So this is quite interesting. I mean, these are the sort of things that you can gather with this software, but mainly I was using it for doing a 24-hour capture of the current of the energy used very accurately.